In this video, I'm going to show you a different approach to explaining what a partial correlation is. I'm going to use Venn diagrams and then show you in SPSS what a partial correlation does. Okay, so let's take a variable. TV, that's what we're going to, that's going to be our Y variable. And let's say it is weight loss. Okay, so we have a variable called weight loss. And I want you to imagine that this circle is the total variance in weight loss. Remember, variance is the average distance away each individual piece of data is in that data set, how far away it is from the mean, right? So some people will have more weight loss than the mean. Some people have less weight loss than the mean. And that spread of the numbers away from the mean, that's variance. And that's what we're going to try to explain here. So let's add a second variable, right? This is going to be a predictor variable. So this little circle here represents the total variance in calories. Remember that. So the circles represent variance, total variance. And I'm going to add a third variable, which would be the second predictor variable. And again, this is total variance, and let's call this one exercise. So IV2 is exercise, DV is weight loss, and IV1 is calories. So we know that the less calories a person takes, the more weight he's going to lose. Same with exercise. The more a person exercises, the more weight that person is going to lose, etc., etc. So we're gonna go ahead and run this. So here's my visual interpretation of a correlation. So when we run a correlation between calories and weight loss, remember the circles are the variance, you get some kind of weird overlap of variance, right? So some of the variance in calories is shared by the variance in weight loss. That's what we call shared variance. Its real name is covariance, but you can think of it as a correlation. I'll explain why here in a second. But again, you see that little football in here? That is shared variance between calories and weight loss. That is part of the correlation. And let me pull up the formula real quick to get the correlation from the covariance. So, right, again, that football is the covariance. If you divide that by the standard deviation of your X, which would be your calories, times the standard deviation of your Y, which would be your weight loss, that standardizes it, and a standardized covariance is what we call a correlation. So that's what that is all about. But again, just think of them as correlations because it literally is. So again, shared variance. But there is a third variable, right? That's our exercise. That's our second IV. We don't know if exercise is sharing any variance with calories. But if we ran a correlation between exercise and weight loss, right, it would look just like calories, right? Exercise variance is going to be shared with some of the weight loss. But what the partial does, it looks for the overlap. So let me try to show you what that looks like in a picture. We don't know what it looks like until we run it. I'm going to run it here in SPSS. But right, like if it was like this kind of indicates that exercise has a little tiny shared variance with weight loss and no shared variance between calories and exercise, which I kind of feel is not true. These two have to be related somehow. You know, every time I exercise, I get really, really hungry. You know, I get hungry all the time anyway. But if it overlaps like that, that's when partial correlations become very important. So keep that in mind. I'm going to go ahead and run it in SPSS. SPSS to the rescue. So I forgot to tell you that all of these variables are continuous variables. Don't try to use categorical variables. Some teachers do. I know they do, but I'm not familiar with that. I'm not saying it's wrong. I'm just saying don't do it. So let's do our partial correlation. We're going to go to Analyze, Correlate, Bivariate. And I'm just going to do these two first of all. I'm going to take exercise out to show you the correlation between weight loss. Oop, you can't see this. I'm going to show you just the correlation between weight loss and calorie intake. And I'll click OK down here. And yeah, they're strongly correlated, right? 0.486. And it's significant. So, in other words, calorie intake and weight loss share a lot of the same variance. So now we're gonna partial out or control for exercise. We're gonna go to analyze, correlate. Gonna go to partial. Bam. And I already put them in there. So, but there's the original correlation between weight loss and calories, and I'm controlling for minutes of exercise. And don't worry about the two-tail, one-tail thing. We always go two-tail. And oh my gosh, look, there it is right there. Let's pull it up. So after controlling for minutes of exercise, that's the controlled variable right there, the relationship, the correlation between weight loss and calorie intake dropped down to 0.138, and here's the money. It is no longer significant. Got that? So after partialing out or controlling for exercise minutes, the relationship between calories and weight loss is no longer significant, which means that your model is going to look something like this. Let's see if I can't get it in there. Nah, it's not going to look like that. It's going to look more like this, right? Your exercise variance is basically controlling most of the calorie variance as well. So if you subtracted out this overlap between exercise and weight loss, you'll see that the area of shared variance for calories and weight loss is practically nil, and that's what that's saying. So one last thing before I go, I'm going to go back to an easier drawing here, this one. So remember, if this is the covariance, the shared variance between calories and weight loss, if you take that correlation and if you square it, you got to square it, that becomes the effect size. So the effect size, or the magnitude of effect between calories and weight loss, would be whatever this correlation is squared. That's why we have a separate section on partial correlations and semi-partial correlations. But again, square the correlation between two variables, that becomes the effect size. Okay, that's it. Okay, I hope this stuff helps. MGZ, out.